Hello everyone, this demonstration presents an Inter-PLMN handover scenario using blockchain-based authentication in a 5G O-RAN network. Let me first describe our testbed. On the left, we have the home network, an O-RAN deployment based on OpenAir interface in VM1, and the core network running Open5GS in VM2. On the right, the visited network follows the same structure, with the RAN in VM5 and the core in VM4. A router in VM3 separates the two domains, and a mobile UE in VM6 connects to the RAN through the OIE RF simulator. The UE follows a predefined trajectory from DU1 in the home network toward DU2 in the visited network. The handover is triggered by an NSRP threshold, and the target cell is selected as the nearest DU. We begin by verifying that no blockchain peer is running using Docker PS. We then deploy the Hyperledger Fabric network with one peer per PLMN and one order node running the wrapped consensus. As you can see, all blockchain components are now up and running as Docker containers, and we monitor blockchain metrics in real time with net data. Next, we launch the home network. We start first the core, then the CU, and finally the DU. The cell now is in service. We repeat the same steps for the visited network. We clean the core log files to track the authentication procedures. The UE now connects to the home PLMN. We have registration request, registration acceptance, response, and the tunnel interfaces. We verify the created tunnel interface with a trace route command. Following the access protocol, the UE first registers using the standard 5G ACAP procedure. You can see the authentication vector in OSF logs. Then generates a handover ticket and stores it on the blockchain. You can see the block commit details in the handover log file. This is what we call it, the pre-handover preparation. We clean the core log files for both home PLMN and visited PLMN. Then we start a video streaming session to evaluate service continuity. Now we begin the mobility phase as the UE moves away from the visited Gnode B. So we observe the degradation of LSRP and SENR along with the packet retransmission as radio conditions worsen. When the LSRP drops below -70 dBm, we send the registration request and we trigger a handover, and the authentication phase begins using XAuth protocol. The interface is created. If we look at the home core network, there is no 5G ACAP procedure, only the deregistration. Instead, we see the blockchain ticket request from the visited PLMN, confirming that authentication in the visited network is performed entirely through the blockchain. Finally, NetData visualizes the radio metrics from the UE side: LSRP, LSRQ, packet error rate, packet delivery rate, blur, and downlink MCS, as well as the data rate over the full trajectory, which clearly shows the service interruption time during the handover. Thank you.